So this is going to be the last problem of this worksheet. It says you shot a gun straight up in the air with a velocity of 500 meters per second. How long will it take before it hits the ground again? Okay, so the situation is we're shooting a gun straight up in the air. Actually, a bullet. You shot a gun straight up in the air. All right, so I guess it's gonna be we shot the bullet straight up in the air and it's coming back down. So once again, we're going to be saying that this is our initial position. This is our final position. Once again, the whole reason why we like that is because we know that this is going to be equal to 0. Oh, that was a bad line right there. Okay, so what is our given information? What do we have here? So what does this 500 meters per second represent? That's our initial velocity, right? And by now you should know this. And what's our initial height? Does it say anything about the height of it? Do we care about the height of this at all? No, right? And so I guess that's the thing that we don't care about, because it sounds like that it's asking how long will it take before it hits the ground again. I just want to say that, hey, you know what? If English is your second language, it's very common to actually be phrasing things in the English language, saying how long will it take, and that's basically referring to time. I know it says a long right here, and you might be thinking distance or like a height or something like that, but in this context, it says how long will it take before it hits the ground again. We're referring to the time. Another context where you might say how long will it take, you might say how long will it take you to go grocery shopping today, or how long will it take you to walk down your school hall. And it's just referring to time. I know it's a little confusing if if English isn't your first language, but we are referring to time right now. So this is the variable that we're trying to find. Okay, so the variable that we simply don't care about, and by the way, I purposely added this in here just because I know that there is a confusion at times with that. So, all right, so the YF is the variable that we don't care about. Let's come over here and look for all the YFs. Okay, so we got YF right here, and once again, we have YF right there. We're not going to be using these two. And scanning through here, we have another YF right there, so we're not going to be using that one. We're going to be using equation number 3 to find our time. VF is equal to V hour delta T. Let's do our substitutions right now. VF okay. Okay, so I guess I could just rewrite this. Isn't this the same as this? Okay, so we have it rewritten in this form. Now, once again, we do have two terms over here. Terms are once again separated by plus signs and minus signs. We have this term over here, which includes the variable that we're trying to solve for. So let's get rid of this term over here, which is a positive 500, simply by subtracting 500 on both sides of the equation. And then we have a multiplication of negative 9.8. So how do we get rid of multiplication of negative 9.8? Let's divide both sides by negative 9.8. So I'm just going to do this on the calculator. And if we divide a negative by a negative, what do we get? Positive or negative? A positive. So we have 51.02. Okay, so let's just leave it at 51 seconds is equal to our delta T. Oh, wait a minute. The answer right here is saying that's 102 seconds. Wait a minute, so what is this 51 seconds about? Well, think about it. What is this representing to us? Why did we get this answer? Well, doesn't that represent the time it takes to go from here to here, which is our T rise? and we're trying to find out how long will it take before it hits the ground again. So we're trying to find out this time, the total time. So our total will just be double this, which is equal to our 102. So the t total is 102 seconds. And we're done with that problem.